Ever wonder how you can run a massive global infrastructure, auto-scale to millions of users in literally seconds, and handle oceans of data without racking a single physical server yourself? Well, welcome to the cloud. Hey everyone, I'm Mr. Shah, and you're watching Mr. Shah Explains Tech. In today's explainer, we're totally demystifying the architecture that powers the modern internet. We're going to peel back the layers of data centers, deployment models, and service frameworks just to figure out exactly how this giant engine actually operates. Let's get right into it.
So, here's our roadmap for today. We'll start with what exactly is the cloud. Then, we'll break down public, private, and hybrid models. After that, we'll dive into cloud service models, and we'll wrap it all up with the cloud computing roadmap.
All right, Section 1. What is the cloud? Demystifying the digital sky.
Okay, so to completely shatter this illusion that the cloud is some mystical, intangible thing floating in the air, let's just look at how we used to operate. Historically, your local hard drive was it. That was the absolute boundary of your computing power, right? You saved a file, compiled some code, or ran an app, and it lived entirely on that specific chunk of metal sitting on your desk or in your office's server closet. But the modern paradigm, it shifts that burden entirely. Instead of relying on local, isolated hardware, we're now routing data through high-speed fiber optics to massive, super secure remote data centers. It's a huge fundamental shift from isolated computing to a distributed, hyper-connected infrastructure. It lets us leverage immense hardware capability that we don't even have to buy or maintain ourselves. Pretty wild, right?
So the core truth here is actually remarkably simple. The cloud is, at the end of the day, just someone else's computer. But obviously it's not just one single computer sitting in a basement somewhere. We're talking about thousands upon thousands of highly advanced, heavily optimized servers locked down in physically secure facilities all over the globe. By using really powerful virtualization software called hypervisors, cloud providers can take massive amounts of raw computing power, chop it up into smaller, isolated virtual machines, and just lease it to you on demand over the internet. And you get all that raw computational power without having to worry about hardware maintenance, cooling costs, or even finding the physical real estate for the servers.
Moving right along to Section 2, public, private, and hybrid, the three core cloud types.
You know, not all clouds are built the same way. When an organization decides to migrate their infrastructure, they really have to choose between three primary deployment models: public, private, and hybrid. You can kind of think of these as different types of digital real estate that you can either lease or own. And each of these models carries incredibly unique implications for cost. We're talking specifically about the shift from massive upfront capital expenditures to much more flexible operational expenditures. Plus, there's strict considerations for data security, compliance, and overall dynamic scalability.
Let's break those down. In a public cloud, so think of major players here like AWS, Google Cloud, or Microsoft Azure, you're entering what we call a multi-tenant environment. You're securely sharing massive underlying hardware infrastructure with other companies. Because the provider benefits from massive economies of scale, it's highly cost-effective and basically infinitely scalable on demand. You pay exactly for what you use. It effectively turns computing into a utility, kind of like your electricity bill. On the flip side, the private cloud is a single-tenant environment. You or your company actually own dedicated infrastructure that isn't shared with anyone else. Now sure, it requires a much higher upfront capital expenditure to build and maintain the whole shebang, but it delivers absolute granular control and the massive security you need for highly sensitive, proprietary, or strictly regulated data.
And that brings us perfectly to the hybrid cloud, which is basically the best of both worlds. It strategically combines the two to give you incredible architectural flexibility. A hybrid model lets a company keep their mission-critical, highly compliant data securely locked down on-premises in a private environment. But here's the cool part. During periods of peak demand, let's say an e-commerce site gets a massive traffic spike on Black Friday, they can execute this awesome process called cloud bursting. They dynamically and temporarily spill over into the public cloud to borrow vast amounts of scalable computing power. This lets them handle the surge flawlessly, pay only for the extra resources they consume during that specific spike, and then just scale right back down when it's over.
That brings us to Section 3, Cloud Service Models Explained, IaaS, PaaS, and SaaS.
Now that we've got a solid grasp on deployment locations, we need to look at how we actually consume these services. A lot of times, this is explained using the famous pizza as a service analogy, which is great because it maps out the strict division of labor between you and your cloud provider. Infrastructure as a service, or IaaS, is the very foundation. Here, you're just renting the raw virtual machines, the storage arrays, and the networking components. Then you step up to platform as a service, or PaaS, which abstracts away the underlying operating systems. The provider just gives you the runtime environments and tools to build your apps without you ever having to manage the back-end hardware or OS updates. And finally, software as a service, or SaaS, is the fully hosted, finished product where you just consume the application right over your web browser.
You can really think of this as a progression of effort and responsibility. With IaaS, you're the architect. You're handed an empty plot of land and raw materials, and you've got to build the entire house from the ground up, managing everything inside it. Moving up to PaaS, you're more like a developer focusing solely on the design. The foundation, the plumbing, the electricity, that's all fully managed by the provider, which lets you just focus on writing and deploying your code efficiently. At the very peak is SaaS. The house is completely built, it's fully furnished, and it's totally maintained. You literally just turn the key and walk in. This is exactly how we use everyday enterprise tools like Salesforce, Google Workspace, or Dropbox. Honestly, you don't care what server it's running on, you just need it to work perfectly every single time.
Let's head into Section 4, the Cloud Computing Roadmap, the backbone of modern tech. So, we've decoded the terminology, but the real-world impact of all this is absolutely staggering. The cloud is literally the invisible engine powering nearly every single modern digital innovation. It provides the immense, raw computational horsepower required to train advanced AI models, crunching petabytes of data in a matter of hours instead of decades. It gives us the global, low-latency networks that make instant e-commerce, seamless software deployments, and real-time video streaming possible across entire continents. Understanding this architecture, it's no longer just about knowing the jargon. It is an absolute prerequisite for anyone navigating, managing, or building a career in today's tech ecosystem.
Now, this explainer has given you the macro-level map of the digital sky, but hey, we definitely aren't stopping at mere theory. Keep your notifications on, because in the near future, I'm going to be dropping deep dive tutorials where we'll actually get our hands dirty with real cloud infrastructure. We're going to transition from simply reading the map to actively driving on the road together, provisioning actual servers, and configuring real-world enterprise networks.
To wrap up, I want to leave you with one final, kind of provocative thought. If the cloud is ultimately just someone else's computer, who is truly responsible for securing the cloud of tomorrow? As enterprise reliance on these shared networks becomes absolute, the shared responsibility model for security really becomes the single most critical challenge we face. Yes, providers secure the physical hardware, but you still have to secure your data and applications. Definitely think about that the next time you deploy a workload. I'm Mr. Shah. Thank you so much for exploring this architecture with me today, and I'll see you in the next explainer.